This isn't just a weapon. It's a nightmare that falls from the heavens. No explosions, no radiation, no warning. Just pure kinetic devastation dropping from orbit at 10 times the speed of sound. The United States military has been quietly developing something that could rewrite the rules of warfare forever. They call it Project Thor. A system so simple it's terrifying, so powerful it makes nuclear weapons look outdated. Tungsten rods launched from space, each one capable of obliterating entire city blocks without leaving a trace of fallout behind. While the world argues about treaties and nuclear disarmament, America has found a loophole. A weapon that doesn't explode but destroys everything in its path through sheer velocity and mass. This isn't science fiction anymore. This is the future of conflict, and it's already being built above our heads. How did we get here, and what happens when the first rod falls? The origins of orbital destruction. In the 1950s, while most military minds focused on bigger bombs and faster missiles, one man was thinking differently. Jerry Pournelle, a brilliant strategist, looked up at the sky and saw something everyone else missed. Not a place to launch weapons from, but a place to drop them. His concept was elegantly simple. Why waste energy on explosives when gravity could do the work for free? Pournelle's vision wasn't about complex chemical reactions or nuclear fission. It was about physics in its purest form. Take a heavy object, lift it high enough, and let it fall. The higher the drop, the more devastating the impact. But Pournelle wasn't thinking about dropping rocks from a cliff. He was thinking about dropping precision-engineered projectiles from the edge of space itself. The concept sat in classified files for decades, too ambitious for the technology of its time. But as America's space capabilities grew, so did the possibility of turning Pournelle's dream into reality. The Cold War demanded new thinking, new weapons, new ways to project power across the globe. Project Thor wasn't just born from military necessity. It was born from the realization that space wasn't just the final frontier. It was the ultimate high ground. The beauty of the system lies in its simplicity. No nuclear reactors, no chemical explosives, no complex guidance systems, just tungsten rods, each one 20 feet long, falling from orbit with the force of a meteor. The same force that carved craters into the moon would now be weaponized, controlled, and aimed at targets below. But simplicity doesn't mean easy. The engineering challenges were immense. How do you store tungsten rods in space? How do you aim them? How do you ensure they hit their targets with precision? These questions would drive decades of secret research and development. The mechanics of devastation. Project Thor operates on a principle that's both ancient and futuristic. It's the same force that David used against Goliath, scaled up to cosmic proportions. The system consists of 2 satellites working in perfect coordination. One acts as the targeting platform, scanning the Earth below with sensors so advanced they can identify individual vehicles from hundreds of miles above. The other satellite carries the payload, 20-foot tungsten rods waiting silently in space. When a target is identified, the process begins. The targeting satellite locks onto the coordinates, calculating wind patterns, atmospheric conditions, and the Earth's rotation. Every variable must be perfect because there's no second chance. Once a rod is released, physics takes over. The tungsten projectile begins its descent, accelerating under Earth's gravitational pull. As it falls, the rod gains speed. Not just any speed, but velocity that reaches 10 times the speed of sound. At those speeds, the rod becomes more than a projectile. It becomes a force of nature. The atmosphere can't slow it down significantly. The rod punches through air like it's barely there, creating a trail of superheated plasma as it descends. The choice of tungsten isn't accidental. This metal is one of the densest materials on Earth, nearly twice as heavy as lead. It's also incredibly hard, able to withstand temperatures that would melt steel. When a tungsten rod hits its target, It doesn't just penetrate the surface. It drives deep into the earth, hundreds of feet down, destroying everything in its path. The impact creates a shock wave that ripples outward, collapsing buildings, shattering foundations, and turning concrete into dust. The energy released is equivalent to a nuclear explosion, but without the radiation, without the fallout, without the long-term contamination, it's destruction in its purest form. But the real genius of Project Thor isn't just in the rods themselves. It's in the targeting system. Modern satellites can track moving targets in real time, adjusting the rod's trajectory even after release. The system can hit a building, a bunker, even a moving vehicle with surgical precision. There's nowhere to hide from a weapon that strikes from directly above. The psychological impact is just as devastating as the physical destruction. Imagine living under a sky where death could fall at any moment, without warning, without sound, without the ability to intercept or defend. Traditional missile defense systems are useless against kinetic weapons. You can't shoot down a tungsten rod traveling at hypersonic speeds, breaking international barriers. The genius of Project Thor extends beyond its destructive capability. It exists in a legal gray area that makes it nearly impossible to ban. The 1967 Outer Space Treaty, signed by most of the world's nations, explicitly prohibits the deployment of nuclear, biological, or chemical weapons in space. But tungsten rods aren't nuclear, biological, or chemical. They're kinetic weapons, powered by gravity and momentum. This loophole wasn't accidental. Military strategists understood that future conflicts would require new types of weapons, weapons that could circumvent existing treaties while delivering devastating results. Project Thor represents the ultimate expression of this philosophy. It's a weapon that's technically legal under current international law, yet more destructive than many banned weapons. The implications are staggering. While nations spend billions developing missile defense systems, Project Thor renders those systems obsolete. You can't intercept a tungsten rod traveling at Mach 10. You can't negotiate with gravity. You can't defend against physics itself. The weapon doesn't just change military tactics. It changes the fundamental nature of warfare. Countries around the world have recognized this threat. Russia and China have repeatedly called for new treaties specifically addressing space-based kinetic weapons. They've proposed legally binding agreements to prevent an arms race in orbit. But the United States has consistently rejected these proposals, arguing that they're fundamentally flawed because they don't address ground-based weapons. This rejection isn't just diplomatic posturing. It's a clear signal that America intends to maintain its advantage in space-based warfare. The establishment of the U.S. Space Force in 2019 wasn't just about protecting satellites or exploring the cosmos. It was about weaponizing the ultimate high ground. Foreign ministers from Germany and Russia have expressed deep concern about the militarization of space. They've warned that weapons like Project Thor could trigger a new arms race, one that makes the nuclear standoff of the Cold War look primitive by comparison. When weapons can strike anywhere on Earth within 15 minutes, the concept of national borders becomes meaningless. The cost of cosmic destruction. Building the ultimate weapon comes with an ultimate price tag. Every pound of material launched into orbit costs approximately $10,000 using current technology. A single tungsten rod, weighing more than 20,000 pounds due to the metal's incredible density, would cost around $230 million just to get into space. That's more than the cost of most nuclear weapons. It's more than the price of advanced fighter jets. It's an investment that would make most military budgets tremble. But the calculations become more complex when you consider the long-term strategic value. A tungsten rod can be stored in space indefinitely, requiring no maintenance, no fuel, no ongoing costs. It's a weapon that waits patiently until needed. The infrastructure required for Project Thor is equally expensive. Launching satellites, maintaining orbital platforms, and developing the targeting systems requires billions in research and development. The total program cost could easily exceed the price of entire aircraft carrier battle groups. But military strategists argue that the psychological impact alone justifies the expense. The knowledge that tungsten rods are orbiting overhead, ready to strike at any moment, changes the behavior of potential enemies. It's a deterrence on a cosmic scale, a threat that can't be ignored or defended against. The economic implications extend beyond military budgets. Countries that feel threatened by Project Thor might be forced to develop their own space-based weapons, triggering an arms race that could cost trillions globally. The peaceful exploration of space could be replaced by an orbital battlefield where nations compete for the ultimate high ground. Yet the United States military sees these costs differently. When compared to the $212.5 million projected for each next-generation intercontinental ballistic missile, the gap narrows considerably. Traditional weapons require constant maintenance, fuel, and replacement parts. They can malfunction, be intercepted, or become obsolete. A tungsten rod in orbit is different. It's a permanent asset, a sword of Damocles hanging over the entire planet. The economics also factor in delivery time. Traditional military strikes require hours or days of preparation, moving aircraft carriers, positioning submarines, coordinating with allies. Project Thor eliminates this delay entirely. From target identification to impact, the entire process takes 15 minutes. That speed has value beyond any price tag. Defense contractors have already begun calculating the return on investment. A single successful strike could eliminate threats that would otherwise require months of conventional warfare. The precision of kinetic weapons means less collateral damage, fewer civilian casualties, and cleaner military objectives. For strategists, these advantages justify almost any cost. The dawn of kinetic warfare. The world stands at the threshold of a new era. Traditional warfare, with its explosions and chemical reactions, is giving way to something far more elegant and terrifying. Kinetic weapons represent the purest form of destruction, where mass and velocity combine to create devastation that makes conventional explosives look primitive. Project Thor isn't just changing military strategy, it's rewriting the fundamental rules of conflict. When weapons can strike anywhere on Earth within minutes, the concept of safe zones disappears. Command bunkers buried deep underground become vulnerable. Mobile missile launchers can't outrun gravity. Aircraft carriers become sitting ducks beneath an orbital firing squad. The psychological warfare aspect is equally revolutionary. Enemies can't hear tungsten rods approaching. There's no radar signature to detect, no heat signature to track. The first sign of attack is the impact itself. This invisible threat creates a level of psychological pressure that traditional weapons simply can't match. Military analysts predict that kinetic weapons will force a complete rethinking of defensive strategies. Underground facilities must be built deeper. Mobile assets must move faster and more unpredictably. Communication networks must be hardened against the electromagnetic pulse created by hypersonic impacts. The entire architecture of modern warfare is being rebuilt around the threat of orbital strikes, but the implications extend far beyond military applications. The same technology that can destroy bunkers can also be used for precision strikes on infrastructure. Power grids, communication networks, transportation hubs, all become vulnerable to weapons that can't be intercepted or defended against. The line between military and civilian targets blurs when any structure can be obliterated from space. The international community watches with growing alarm as this technology develops. Nations that once felt secure behind oceans or mountain ranges now face the reality that distance provides no protection. The ultimate high ground belongs to whoever controls orbital space, and currently, that's the United States, racing toward orbital supremacy. The establishment of the U.S. Space Force wasn't just about protecting satellites or exploring distant planets. It was about recognizing that space has become the ultimate battlefield. Every nation with ambitions of global power must now consider not just land, sea, and air superiority, but control of the void above. Russia and China haven't ignored this shift. Both nations have accelerated their own space programs, developing anti-satellite weapons and orbital platforms. The race isn't just about who can deploy tungsten rods first. It's about who can control the orbital environment that makes such weapons possible. The technology behind Project Thor has applications beyond tungsten rods. The same principles that guide kinetic weapons can be applied to orbital manufacturing, asteroid mining, and planetary defense. Nations that master this technology don't just gain military advantages. They gain control over the next phase of human development. Space-based weapons represent a fundamental shift in the balance of power. Throughout history, military dominance has belonged to nations that could control key geographic positions: mountain passes, river crossings, sea lanes. Now, the key position is orbit itself. Nations that can't reach space effectively become secondary powers, dependent on those who control the high ground above. The arms race in space is accelerating at an unprecedented pace. Every satellite launch, every orbital platform, every space-based sensor becomes a potential component in a weapons system. The peaceful exploration of space is being overshadowed by the military potential of orbital assets. International efforts to prevent this militarization have repeatedly failed. The fundamental problem isn't just political, it's technological. The same capabilities needed for peaceful space exploration can be easily converted to military purposes. A satellite that can dock with space stations can also deliver weapons. A system that can move asteroids can also drop tungsten rods. The transformation of space from a realm of wonder to a theater of war reflects humanity's perpetual struggle with new technology. Every advancement, from gunpowder to nuclear energy, has been weaponized. Space represents the ultimate frontier for this pattern, where the weapons are as vast and terrible as the void itself. As nations compete for orbital supremacy, the Earth below becomes increasingly vulnerable. The same technology that promises to unlock the resources of the solar system also threatens to rain destruction from the heavens. Project Thor stands as both a symbol of human ingenuity and a warning about the price of technological advancement. The future of warfare isn't being written in laboratories or testing grounds. It's being written in the silent darkness of space, where tungsten rods wait patiently for their moment to fall. When that moment comes, the world below will discover that the ultimate weapon doesn't need explosives. It only needs gravity, velocity, and the will to use them. The race has already begun, and the stakes couldn't be higher. While diplomats debate treaties and politicians argue over budgets, engineers in secret facilities are solving the technical challenges that will determine who controls the ultimate weapon. The questions aren't theoretical anymore. They're practical, immediate, and terrifying. How do you store 20-foot tungsten rods in the vacuum of space without them drifting away? How do you maintain orbital platforms for decades without regular maintenance missions? How do you ensure that a weapon system operating hundreds of miles above Earth can hit a target the size of a building with perfect accuracy? These aren't problems for the distant future. They're problems being solved right now. The storage challenge alone represents a masterpiece of engineering. Tungsten rods must be held in perfect alignment within their orbital platforms, protected from the extreme temperature variations of space, while remaining ready for instant deployment. The mechanism that releases them must function flawlessly after years of dormancy, operating in conditions that would destroy most mechanical systems. Temperature control becomes critical when dealing with materials that will experience the friction of atmospheric entry. The rods must maintain their structural integrity during the transition from the absolute cold of space to the searing heat of hypersonic flight. Engineers have developed specialized coatings and alloys that can withstand these extreme transitions without losing their penetrating power. The targeting systems represent perhaps the most sophisticated technology ever deployed in orbit. Each satellite must track multiple targets simultaneously while calculating the complex physics of orbital mechanics. The Earth's rotation, atmospheric conditions, and gravitational variations all affect the trajectory of falling rods. Computers must process these variables in real time, adjusting for factors that change by the second. But the most remarkable aspect of Project Thor isn't its complexity. It's how it makes that complexity invisible. From the perspective of military commanders, the system operates with elegant simplicity. Identify a target, authorize the strike, and watch as physics does the rest. No fuel requirements, no ammunition resupply, no maintenance schedules. Just pure, reliable destruction on demand. The testing phase has been shrouded in secrecy, but hints emerge from budget allocations and personnel transfers. Aerospace engineers specializing in hypersonic flight have quietly moved to classified projects. Materials scientists working with ultra-dense alloys have vanished from public research. The signature of a massive military program appears in the shadows of official documents. Satellite launches have increased dramatically, but their payloads remain classified. Orbital platforms described as communication satellites exhibit unusual power requirements and thermal signatures. The infrastructure for Project Thor is being assembled piece by piece, hidden in plain sight among legitimate space missions. The testing of individual components has likely been ongoing for years. Computer simulations can model the physics of falling tungsten rods, but real-world testing requires actual drops from orbital altitudes. Remote ocean areas provide perfect testing grounds, where rods can be dropped without risk to populated areas, while their impact patterns are studied and refined. Each test reveals new challenges and solutions. The electromagnetic pulse created by hypersonic impact can disrupt nearby electronics. The acoustic signature of a tungsten rod's passage through atmosphere creates a unique sound that could serve as an early warning system. The crater patterns provide forensic evidence that could identify the weapon system used. These technical details matter because they determine the weapon's effectiveness against different types of targets. Underground bunkers require different rod configurations than surface installations. Mobile targets need different targeting algorithms than stationary ones. The versatility of Project Thor lies in its ability to adapt to virtually any military objective. The manufacturing process for tungsten rods represents industrial capability that few nations possess. The metal must be refined to extreme purity, then shaped with precision that tolerates no defects. A single flaw could cause a rod to tumble during descent, destroying its accuracy and penetrating power. The production facilities required for this work are themselves strategic assets. Quality control becomes critical when dealing with weapons that can't be recalled once deployed. Every rod must be perfect, every guidance system flawless, every targeting calculation precise. The margin for error approaches zero when dealing with weapons that travel at 10 times the speed of sound. The launch logistics present their own challenges. Getting tungsten rods into orbit requires rockets capable of lifting extraordinary weights. The dense metal pushes payload capacities to their limits, requiring specialized launch vehicles or multiple missions to deploy a single weapons platform. Each launch represents a massive investment in both money and technical resources. But perhaps the most challenging aspect of Project Thor isn't technical, it's operational. How do you command weapons that orbit the Earth every 90 minutes? How do you maintain communication with platforms that disappear behind the planet for extended periods? How do you ensure that orbital weapons remain under positive control when they're beyond the range of traditional command systems? The command structure for space-based weapons must account for the unique challenges of orbital mechanics. Ground-based commanders can't simply pick up a radio and contact their weapons platforms. Communication requires satellite networks, relay stations, and backup systems that can function even when primary links are severed. The decision-making process for deploying kinetic weapons from space involves considerations that didn't exist with traditional weapons. Once a tungsten rod is released, it cannot be recalled or redirected. The commitment to destruction is absolute and irreversible. Military commanders must be certain of their targets before authorizing strikes that will obliterate everything within hundreds of feet. The authorization protocols for Project Thor likely involve multiple levels of approval, from field commanders to the highest levels of government. The power to rain destruction from space cannot be delegated lightly. Yet the speed required for effective use of kinetic weapons demands streamlined command procedures that can function within the 15-minute window from target identification to impact. Training programs for space-based weapons operators must prepare personnel for scenarios unlike anything in military history. Traditional weapons training focuses on ammunition management, mechanical maintenance, and tactical deployment. Orbital weapons require understanding of physics, orbital mechanics, and the unique challenges of operating in the space environment. The psychological preparation for using Project Thor presents its own challenges. Operators must be prepared to unleash destruction with a precision and power that exceeds most nuclear weapons, yet without the dramatic visual cues that accompany traditional military strikes. The weapon's silence and invisibility create a disconnect between action and consequence that requires special mental preparation. Intelligence gathering takes on new dimensions when dealing with orbital weapons. Traditional reconnaissance focuses on enemy movements, weapon deployments, and tactical positions. Space-based weapons require global intelligence networks that can identify targets anywhere on Earth within minutes. The surveillance capabilities needed to support Project Thor dwarf those of conventional military systems. The targeting intelligence must be updated continuously as satellites orbit the planet. A target that appears stationary from one orbital pass might have moved significantly by the next. Mobile targets require predictive algorithms that can anticipate movement patterns and calculate intercept trajectories for weapons that take minutes to reach their targets. Electronic warfare capabilities become crucial when dealing with space-based weapons. Enemy nations will inevitably develop systems to jam satellite communications, disrupt targeting sensors, or interfere with orbital platforms. The weapons systems must be hardened against these threats while maintaining their ability to function in contested electromagnetic environments. The maintenance of orbital weapons platforms presents logistical challenges that have no precedent in military history. Traditional weapons can be serviced by ground crews supplied with spare parts and repaired when damaged. Orbital platforms operate in an environment where human intervention is extremely limited and prohibitively expensive. Robotic maintenance systems must be developed to service weapons platforms without human intervention. These systems must be capable of diagnosing problems, performing repairs, and replacing components while operating in the vacuum of space. The complexity of maintaining precision weapons systems under these conditions pushes automation technology to its limits. The longevity requirements for orbital weapons exceed those of any military system ever deployed. A tungsten rod platform might remain in orbit for decades, waiting for the moment when it's needed. Every component must be designed for extreme durability, from the guidance computers to the mechanical release systems. Solar radiation, micrometeorite impacts, and the extreme temperature variations of space create a hostile environment that gradually degrades all materials. The weapons platforms must be designed to withstand these conditions while maintaining their precision and reliability over extended periods. The strategic implications of deploying Project Thor extend far beyond immediate military applications. Nations that possess orbital kinetic weapons gain leverage in international negotiations that conventional military power cannot provide. The ability to strike anywhere on Earth within minutes changes the fundamental dynamics of diplomacy and conflict resolution. Allied nations must consider how space-based weapons affect their own security arrangements. Traditional mutual defense treaties assume that threats can be identified and responded to with conventional timeframes. Orbital weapons compress response times to minutes, requiring new forms of cooperation and coordination between friendly nations. The proliferation potential of kinetic weapons technology creates long-term strategic concerns. While the initial deployment of Project Thor might provide the United States with a decisive advantage, the underlying technology cannot remain secret forever. Other nations will inevitably develop their own orbital weapons, creating a new form of arms race that extends into space. The environmental impact of kinetic weapons testing and deployment raises questions that military planners are only beginning to address. The orbital debris created by weapons platforms and their operations could interfere with peaceful space activities. The electromagnetic pulses generated by hypersonic impacts could disrupt civilian communication systems. International space law must evolve to address the reality of orbital weapons. The existing treaties that govern space activities were written before kinetic weapons became feasible. New agreements must balance the legitimate security interests of nations with the need to prevent the militarization of space from spiraling out of control. The economic implications of space-based weapons extend beyond their massive development costs. Nations that feel threatened by orbital kinetic weapons might be forced to invest in defensive measures, underground facilities, or their own space-based deterrents. The global economy could be reshaped by the need to defend against threats that rain down from space. The psychological impact on civilian populations cannot be underestimated. Living under skies that might deliver instant destruction without warning creates a form of existential anxiety that previous generations never experienced. The knowledge that tungsten rods orbit overhead, ready to strike at any moment, changes the fundamental human relationship with the heavens above. Military doctrine must be completely reconsidered in light of orbital weapons. Traditional concepts of battlefield preparation, supply lines, and defensive positions become meaningless when the enemy can strike from space. Combat formations, equipment deployment, and strategic planning must account for threats that can appear anywhere without warning. The training of military personnel must incorporate the reality of space-based weapons. Soldiers must be prepared to operate in environments where traditional cover and concealment provide no protection from orbital strikes. Command structures must be designed to function even when headquarters and communication centers can be obliterated within minutes. As Project Thor moves from concept to reality, the world watches with a mixture of fascination and terror. The ultimate weapon doesn't announce itself with mushroom clouds or chemical burns. It simply falls from the sky, faster than sound, harder than diamond, carrying the force of gravity itself. When it strikes, the only evidence is a crater and the knowledge that warfare has changed forever. The silence of space holds new terrors now. Somewhere above, tungsten rods wait patiently for their moment to fall. When that moment comes, the world below will discover that the most devastating weapons don't need explosives. They only need physics, precision, and the willingness to use them.